Hey, we're going to do a quick review of titration. So what you probably need to know is what are the point products of acid and base reactions. So we're going to go over that. So a titration is just a controlled process of an acid or base neutralization. It's kind of used in the lab if you find an acid, something that's marked and you don't know its molarity, how to determine that. Okay, so it's the unknown is your molarity. So here are some of the objectives. We're going to define the products of an acid and base reaction. We're going to explain how acid and base titration is used. And we're going to explain the concept of equivalence in reaction and the endpoint as well, and the relationship with equivalence in titration. So as I said, you have a problem. You find a bottle of OH that has no concentration written on it. You want to find out what the concentration is. Remember, chemistry is a science of commerce, and maybe you want to sell this stuff. So how can that be done? Well, you put a certain volume of the base in a barrette. So that's what a barrette looks like. And we would set this up in the classroom. This is actually a cool lab to do. And then you would place a certain volume of a standard solution of an acid, something that you know, and some phenolphthalein in an Erlenmeyer flask. So your acid with phenolphthalein would be in an Erlenmeyer flask. Now remember, phenolphthalein turns purple, upside down P for base. So that's what you would do right there. And you would add, excuse me, the acid until the indicator begins to turn color. I'm sorry, you would add the base until the indicator starts to turn color, and then you would record the volume of the base necessary to neutralize. Man, I'm having a tough time talking today. So the problem is that the point where the indicator turns color is called the endpoint. Okay, that's important to note. So that means that your experiment, your titration, has ended. Because the indicator could not turn color at a perfect pH, it might be a little bit off from what's called the equivalence point. Now, today we have instruments and stuff to do that. You can just put a computer and a sensor in there, and you could figure it out. It would be called a pH meter. But before pH meters and before calculators and stuff like that, this is what we would do. All right, so the endpoint is the pH at which the indicator has changed color. So your experiment is over. It's ended. The phenolphthalein has turned pink. However, phenolphthalein turns pink around 8. So you're past your neutral point, right? So your experiment is over, but it's not a perfect science when you're doing it through titration. The equivalence point, again, is the point in which the pH turns 7, right? It's the equivalence, so meaning that you have the same amount of H's and OH. The concentration of hydronium is equal to the concentration of hydroxide. So again, this is determined by a pH probe or pH indicator of some sort that could read it at 7. You might hear my dog in the background. She wants to get a squirrel. Best indicators give the endpoint that's the closest to the equivalence point. All right, so that's how you choose it. Phenolphthalein for our means would be the best, and it's the most common used. From thymol blue does a nice job as well. So again, what occurs at the endpoint of titration? The endpoint is the pH on which the indicator that has been added to the titration setup turns color. Where do you find your list of indicators? Here we have it. You have a common acid and base indicator table, table M. It's kind of really easy to read. I'm just gonna read one of them for you. I'm gonna start with the top one, methyl orange. So if you look at the color range, it starts off red right? So when you use methyl orange, if it's lower, if the pH is lower than 3.2, it's going to be red. If it's higher than 4.4, it's going to be yellow. In between that range, the 3.2 and the 4.4, it would be red yellow or orange. Same thing with bromothymol blue. It'll be yellow at 6, blue at 7.6. It would be green. Phenolphthalein would be clear at 8.2, pink at 10, but kind of like a very light pink between 8.2 and 10. Litmus, you would have red, blue. Red plus blue gives you red blue. What color is that? Blue and yellow, again, you'd have a bluish yellow, which would be a green, and then same thing with thymol blue. Hope that made sense. What is red plus yellow? Purple. Actually, violet. Okay, Mr. Baldo, my art teacher, would always say purple is not a color. It's violet. All right, so that's titration.